In this video, we are looking at the sum and difference formulas for cosine, sine, and tangent. These formulas will be given for you. You do not have to have these memorized. You will have a page that has all your formulas on it. What we are going to do in this video is learn how to work with these formulas. Notice on the cosine formula that you do the cosine of the first angle times cosine of the second angle. And the sign between the terms is the opposite of the original. And then you do the sine of the first angle and the sine of the second angle. On the sine function, you will do sine cosine, sine of the first, cosine of the second. Keep the operation the same as was originally when you put the operation between the terms. And then have cosine of the first, sine of the second. On tangent, you do tangent functions everywhere. The sign on the numerator is the same as what was in the original. The sign in the denominator is the opposite of what was in the original. On our first example in using these formulas, we need to use either a sum or a difference formula to find the exact value of this function. That means if we have pi in the answer, or if we have a square root in the answer, we are not going to put that into our calculator and find a decimal approximation for it. We are going to leave it with the square roots in the answer, or with pi in the answer. Our first problem that we're going to do is the sine of 165 degrees. You can use any sum or any difference that you want to, but you do want them to be numbers that are special angles on the unit circle. So in looking at the sine of 165 degrees, the first thing that I see is that I could rewrite this as the sine of 45 degrees plus 120 degrees. Those are both numbers from the unit circle. Now, since it is a sine, we have to use the sine version of sum. Well, the sine formula says to do the sine of the first angle times the cosine of the second angle. Leave the operation the same as what you had in your parentheses, and then do the cosine of the first angle times the sine of the second angle. Now use the values from the unit circle and substitute in what you know for each of these. The sine of 45 degrees is square root of 2 over 2 times the cosine of 120 degrees is negative 1/2. We're going to add to that the cosine of 45 degrees, which is also square root of 2 over 2, times the sine of 120 degrees, which is the square root of 3 over 2. Order of operations, we need to do our multiplication first. Radical 2 over 2 times negative 1/2 is going to give me negative square root of 2 over 4 plus square root of 6 over 4. We have a common denominator, so we can write this as one fraction. So we will have negative square root of 2 plus the square root of 6 over 4. This is your final answer. Those two radicals are not like terms because it's two different numbers inside the radical symbol. And the answer says exact value, which means we must leave those radicals in the answer as they are. You are done. On the second example, we want to do a sum or a difference and find an exact value for the sine of pi over 12. So you have to think about the numbers on the unit circle, and none of them are unit over 12. So we are going to have to rewrite and think about them that way. If I think about 3 minus 2, that equals 1. 3 pi over 12 and 2 pi over 12 are numbers that are from the unit circle when they are simplified. So the first thing I'm going to do is rewrite this as the sign of 3 pi over 12 minus 2 pi over 12. There are lots of other ways that you could do this. This is just the first one that I thought of. Well, if I simplify that into numbers that are actually on my unit circle, I'm going to have pi over 4 minus pi over 6. Now we're going to put the sine version into practice, which says we do the sine of the first angle, pi over 4, times the cosine of the second angle. Keep the operation the same, then do the cosine of the first angle times the sine of the second angle. Once you have figured this part out, now substitute in your values. The sine of pi over 4 is the square root of 2 over 2. The cosine of pi over 6 is the square root of 3 over 2. Minus cosine of pi over 4 is also square root of 2 over 2, and the sine of pi over 6 is 1/2. If we do our multiplying, we are going to have the square root of 6 over 4 minus the square root of 2 over 4. And because we have a common denominator, we can write that as one fraction, the square root of 6 minus the square root of 2 over 4. Notice that the numbers are the same. They're in a different order, different signs on them. You will find that this is very common to have a lot of the same types of answers. You're going to leave that alone because you want to leave the square roots as they are. If you put them into your calculator, they are no longer exact values. The point of a problem like example C is to show you that you can go the other direction. Notice we have sine times cosine plus cosine times sine. What that tells me is that the original function that we had was a sine function. The operation in between is a plus. So what I need to do is take my two angle measures of 38 degrees and add 52 degrees. Well, if I simplify that, I have the sine of 90 degrees. Well, I know what the sine of 90 degrees is. The sine of 90 degrees is 1. On our next example, we want to use a sum or difference formula to find the tangent of 75 degrees. The function we're going to use is the tangent. Whether we use a sum or a difference does not matter. What I suggest is use whatever you see first. That will make the most sense to you. When I look at 75 degrees, the first thing that jumps out at me is 45 plus 30. So I'm going to leave the function as tangent, and then I'm going to rewrite 75 degrees as 45 degrees plus 30 degrees. Well, now we're going to put the tangent formula into practice. The tangent formula says to do the tangent of the first angle, keep the operation the same, tangent of the second angle, over 1. Now do the opposite operation, so it'll be minus, and then multiply your two values, tangent of 45 times tangent of 30. The tangent of 45 degrees is 1. The tangent of 30 degrees is the square root of 3 over 3. On the bottom, we're going to have 1 minus 1 times the square root of 3 over 3. So the first thing we're going to do is recognize that we have a fraction with a denominator of 3. I'm going to change my 1 that's in the first term into 3 over 3 so that I have a common denominator. So my numerator will become 3 over 3 plus square root of 3 over 3. My denominator will become 3 over 3 minus square root of 3 over 3. Well, now I have common denominators in each of these, so I'm going to write the numerator as 3 plus the square root of 3 over 3, and then the denominator will become 3 minus the square root of 3 over 3. When you have complex fractions, you multiply by the reciprocal of the denominator. So we would have 3 plus the square root of 3 over 3 times 3 over 3 minus the square root of 3. When you get into this, you see that we have 3 over 3, which equals 1. We can take that out. So our final answer is 3 plus the square root of 3 over 3 minus the square root of 3. You cannot cancel anything in this fraction because there are plus and minus signs in between those items. You can only cancel when you have multiplication. On our next example, we want to do a sum or difference, but this time we're doing it for a cosine function, and we want our sum or difference to be 5 pi over 12. Earlier, we did the sine of pi over 12, and we used 3 pi over 12 and 2 pi over 12, because those were numbers that simplified to equal something from the unit circle. So I'm going to use those same two numbers, but instead of subtracting them, I'm going to add them. So first I'm going to rewrite this as the cosine of 3 pi over 12 plus 2 pi over 12. I know that 3 pi over 12 plus 2 pi over 12 equals 5 pi over 12. Now I'm going to simplify those so that we have the cosine of pi over 4 plus pi over 6. Now we're going to use the cosine version of the formula, which says do the cosine of the first angle, which is pi over 4, times cosine of the second angle, which is pi over 6. Then you subtract and do the sine of both angles, sine of pi over 4 times the sine of pi over 6. Substitute your values in. Cosine of pi over 4 is square root of 2 over 2. Cosine of pi over 6 is square root of 3 over 2. Minus the sine of pi over 4 is square root of 2 over 2. And the sine of pi over 6 is 1/2. Do your multiplication. You're going to get the square root of 6 over 4 minus the square root of 2 over 4. Write it as one fraction. You get the square root of 6 minus the square root of 2 over 4, and that is your final answer. This last example is to show you that sometimes you will need to use these formulas in reverse. When you see a formula that is cosine times cosine and sine times sine, you know that the original function was a cosine function. Our two angle measures are 87 and 93. Because it was minus between them, that means that when we go to one function, it must be plus between them. This becomes the cosine of 180 degrees, and we know that that equals -1. On example 5, we are asked to find the exact value of cosine of a plus b when the sine of a is -4/5 and a is in quadrant 3. So A, you have to recognize here, is an angle, and that angle is in quadrant 3. We are told the cotangent of angle B is -3/4, and B is in quadrant 2. So draw a picture for yourself, just to help you visualize what's going on. Angle A is in quadrant 3. So we have an angle in quadrant 3 where the sine, which we defined to be y over r, is 4/5. The y is 4, the r is 5. It is negative. Remember, r can never be negative. And when you are in quadrant 3, y is negative. If you do the Pythagorean theorem and find the x value, it will be 3, and in quadrant 3, x is negative. Now do the same thing for b. We want to draw an angle b that's in quadrant 2. The cotangent relationship has to be 3/4. So x over y, x has to be 3, y has to be 4. The overall sign is negative, and when you are in quadrant 2, the x is what's negative. And you're probably used to this by now. When you have an x and a y that are 3 and 4, your r is 5. We need to do the cosine of a plus b. So remember that the cosine formula says to do cosine of the first angle, cosine of the second angle, do the opposite operation, so this will be minus, and then do sine of the first angle times sine of the second angle. So we are going to go back to angle A and look for what the cosine would be. The cosine would be -3/5 x over r. The cosine of angle B, if we do x over r, will be also -3/5 minus the sine of angle A we were given, that's -4/5. And the sine of angle B will be +4/5. If you do this multiplication, you will get 9/25 minus -16/25, which gives us 9/25 plus 16/25, but that gives us 25/25, which equals 1. On example 6, we are asked to prove the identities using sum or difference formulas. So we will have an identity given to us, and somewhere in there will be either a sum or a difference formula that we are going to have to put into practice and then simplify in order to do our proof. Our first proof asks us to do the sine of the angles x plus y over cosine x cosine y and prove that that equals the tangent of x plus the tangent of y. The sum or difference formula that comes into play here is in the numerator of the fraction. We have the sine of the angles x plus y. So we're going to do the sum formula for sine over there, which says that the sine of x cosine of y, keep your operation the same, so it is plus, and then we will do cosine of x sine of y over what is already a denominator of cosine x cosine y. And we're trying to show that that equals tangent x plus tangent y. The trick on this is recognizing that we can do fraction rules in reverse. If we have addition in our numerator, we can split this into two fractions that are being added together. So we are going to split this into the sine of x times the cosine of y over the denominator cosine x cosine y, plus the second fraction will be cosine x sine y over cosine x cosine y. Well, now in looking at what we have all these functions that are being multiplied together, but cosine of y over cosine of y equals 1. In the second fraction, cosine of x over cosine of x equals 1. So we are left with the sine of x over the cosine of x plus the sine of y over the cosine of y. But sine over cosine is tangent. So our first term simplifies to be the tangent of x. Second term simplifies to be tangent of y. And that equals where we were trying to get tangent of x plus tangent of y.